Good morning, everybody. Welcome to another lesson at Papa Lin Physics Classroom. Okay, once a while I'll be doing some uploading some videos on physics topics relevant to pure physics and combined science, and I also be reviewing some of the exams papers and test papers that I've been using in class. So if you want to get to these materials, and if they are relevant to you, okay, you might want to subscribe to my channel and actually hit the notification bell so that you will actually be notified whenever I upload these relevant materials to my channel. Okay, and for this particular session, we'll be looking at chapter 3, force and pressure in our combined science physics. Now, in this particular topic here, we'll be touching at two sections. Okay, the first section here, we will be looking at in general what are the forces available in the syllabus. And after that, we'll be touching at how do we add the forces, how do we add these vectors, okay, using certain techniques. Now, for forces in general, okay, we can class it into a forces that is actually a pull or push, and the units that we look at is in terms of Newton. Okay, in general types of forces, we can actually classify them into contact and non-contact forces. Okay, and these are the common contact forces that will appear, and these are the non-contact forces that we actually use in our O-level syllabus. Okay, now, so how or where do we actually see all these forces? Okay, these forces exist in our daily life. Okay, for example, even like simple stuff like car moving on a rough road. Okay, so what are the forces that we are looking at when we have a car in motion? Okay, so examples of forces that we have. Okay, we can have actually the forces in the engine. Okay, which is usually we call it the forward force. Okay, which is what drive or pushes the car forward. Okay, which is here. And we also have the weight of the object itself, which is weight of the car due to the gravity of Earth, which is at the bottom here, which is pulling down. Every time the Mother Earth will pull down the car the way towards the center of gravity. And of course, we will have frictions, which exist along the tire. Okay, and of course, we will have air resistance. And last but not least, okay, because our tires are actually touching the ground. Okay, as a result, the ground will actually exert a force onto a tire, which is what we call normal reaction force. It's like action and reaction forces. Okay, so these are the possible forces that can actually act on the body in motion. Okay, so this is some simple examples that we look at. Okay, of course, throughout the topics or throughout the questions, we'll be looking at other objects in different motions or in different actions, and we'll be examining the forces acting on it separately. Now, what happens is once you actually identify all the forces, what do we do with them? Okay, for example, what happens when I have parallel forces? Okay, when I have parallel forces acting in the same axis. Okay, for example, 3 Newton and 5 Newton. Okay, acting on the object, pushing it to the right. Okay, so now what happens is I can actually actually add them together. Okay, to have what we call a resultant force. So which means that whatever 3 Newton and 5 Newton, these two forces can achieve, I can actually replace it with another force, which is what I call a resultant force, which is what 8 Newton. Okay, so which means whatever I can do with 3 Newton, and 5 Newton together, I can actually equally achieve the same effect by using a 8 Newton force, which is what I call the resultant force. Or sometimes we call it actually the net force. Okay, now same thing is what happens if I have 3 Newton and 5 Newton pulling in different directions. Okay, I can also have a resultant of these two actions, or I can actually, resultant means what? I can actually have a force that can actually mimic the same reactions as these two forces, 3 and 5. And I will actually have the same answer if I have a force, a resultant force, 2 Newton pulling on the object, okay, in the direction shown. So what 2 Newton can achieve, what he can achieve is actually what 3 Newton and 5 Newton can achieve in their respective directions. So the idea of getting a resultant force is not just simply adding the forces together, is I can actually replace all the forces with a single force, okay, which is what I call the net force or resultant force that can actually achieve what other forces, what the respective individual forces can achieve. So it's basically like a 2-in-1 or 3-in-1. So if I have two forces, I want to find the resultant force. It's basically I want a force to actually replace both of them. So it can be simple like 3 and 3. Okay, so I pull 3 to the right, pull 3 to the left, you will find that okay, the resultant force acting on the object is actually 0 Newton. Okay, so it's a typical like I pull one direction each one at each direction. Okay, 1 Newton on the right, 1 Newton on the left. Okay, so because they are opposite and same, whatever action these two forces can actually produce, I can replace it with the resultant force. Okay, that's why we are interested in finding the resultant force, or what we call the resulting vectors. Parallel line is actually quite easy. Okay, so we can just add up just like normal mathematics. Right is positive, left is positive. So I can just add them together. And of course, I represent the resultant force. Okay, take a look at the drawings. Okay, I can actually replace the resultant force. How do I write the resultant force? Okay, I actually denote it with a double arrow sign. Okay, the double arrow denotes the resultant force, or what I call the final force that is acting on the body. Okay, so take note, it's double arrow, it's just convention. Okay, if not, there will be a lot of arrows flying on the bodies. Okay, then now what happens is if the forces is not in parallel, okay, parallel or forces in the same axis, very easy, you can just add them just like math, positive and negative number. But what happens if they are in different direction? For example, you have a 3 Newton and a 5 Newton. Okay, acting at different directions. For example, 60-degree apart. Okay, 4 Newton and 5 Newton. Okay, they are 60-degree apart. That's all. How do I find the resultant force? Okay, I cannot just simply replace 5 Newton and 3 Newton with 8 Newton. I can't. Because when the force is at an angle, the outcome or the effect is actually very, very different as compared to the forces, they are in the same directions. Okay, because of the angle is different, the amount, the angles, the force, the final force that's acting on the object, the resultant force that's acting on the object is not a simple 3 plus 5. Okay, sometimes you end up with having a vectors addition. If I add 5 Newton and 3 Newton this way at an angle, the resultant newtons, the resultant forces could actually be much, much lesser than 8 Newton. Okay, as compared to when they are in the same axis. Okay, like this way. Okay, so we need to have certain ways of adding them. One of the way that we add them is by using what we call a parallelogram method. Okay, it's whereby we actually do what I normally say is that it's a 3-method process, whereby the first method consists of you drawing what you see, what I call monkey see, monkey do. So if I see two forces 60-degree apart. So what do? Is I will actually draw their forces down. Okay, so the first force I see is actually I see 3 Newton, 20-degree down. So what I do is I will measure 20-degree, okay, below the horizon. After that, I will have a 3 Newton forces. And remember, you take a look, how do I draw this 3 Newton? It's based on the scale that I set for myself. So let's say if I set 1 cm is to 1 Newton, I'm actually drawing this 3 Newton, I'm actually representing this 3 Newton in drawing by a 3 cm line. Okay, but of course, first rule of the parallelogram method, I always tell my students is what we see is called monkey see, monkey do. Okay, so if I see 3 Newton here, I will label 3 Newton. I will not label 3 cm. After that, I will make sure that my angles and perspective is correct. So which means based on what I see, okay, the 3 Newton is actually 60-degree away. Okay, or what I call 20-degree below, 40-degree above. Okay, from the 5 Newton. So from this, I will actually draw another 40-degree so that I make sure it's 60-degree here. Just like what I see in the picture, monkey see, monkey do. Then after that, I see a 5 Newton's forces 60-degree away. So 5 Newton is actually 5 cm. So this is what I have. Then after that, what I do for parallelogram method, the second step we have is duplicate the shapes, duplicate the lines on the other side. So what I do is I will duplicate the lines to form a closed rectangle. Okay, or what we call a parallelogram, a slanted rectangle. Okay, so this line, okay, I will actually duplicate here. The shorter length, I will actually duplicate here. Okay, and this is what I call your parallelogram method. Okay, so if in this case, what I did was at the second step, I actually copied the two forces, the line, onto the other side, onto their opposite end. And I will form actually what we call a parallelogram or a closed rectangle. Okay, then after that, what I do is this is my end point, the final point. This is my start point. So what I do is from my start to my end, I will actually draw a line. Okay, connecting the start and end. End as in the final. I drew this point last, okay? So it's the final point. Then after that, what I do is I will connect it from start to end with a double arrow to symbolize resultant force. Okay, so in this way, I actually have done what I call vector additions. I've added two forces, 5 Newton and 3 Newton, vectorially, okay, based on their magnitudes and direction. I've added them together, okay, using vector additions called parallelogram. So the final resultant force that can actually mimic 5 Newton action and 3 Newton action on the body is actually a 7 Newton force that is 18 degrees from the horizon. Okay, so which means this 17 Newton at 18 degree can actually produce all the effect by a 3 Newton and a 5 Newton 60 degree apart. And this is what vector addition is about. And of course, this is not the only way. I actually can look at another method called tip to tail. Tip to tail, loosely speaking, is actually tip of force 1. Sometimes tip, it means the head. Okay, the tip of force 1 touches the tail of force 2. Okay, 2, I would say just a touch. Okay, so tip to tail method means tip of the first force touch the tail of the second force. And of course, before we do this, we must decide which is the first force. Okay, normally I'll choose the one that's like slightly easier to write or easier to draw, easier to measure. Okay, so there's no restriction whether you want the 3 Newton to be first force or 5 Newton to be first force. Okay, so whichever it is, but no matter what is, the orientation must remain the same. For example, if I use 3 Newton, it is 20 degrees below the horizon, it must stay that way. 5 Newton is 40 degrees from the horizon, it also must stay that way one. So what happened now is, take a look. Okay, the first one I have is the 5 Newton. So the 5 Newton one, what I have is actually 40 degrees from the horizon. So what I do is I just copy and paste. Okay, I will just copy and paste. Okay, so 40 degrees, I will just look at the first force, 5 Newton, 40 degrees from the horizon. This is what I did. After that, remember, tip of force 1 touches tail of force 2. So this is my force 1. Tip means the head. Okay, so this is the tip of force 1. Okay, it should actually touch the tail of the second one. So where do I find the second force? The second force is this 3 Newton, which is below the 20 degree line. So same thing is, I will make sure is the orientation cannot change. So I will just shift the force 3 Newton. I will just shift it from the bottom. I will shift it all the way up. Okay, so that it touches the tail. It touches the tip of my force 1, which is 5 Newton. So what I do now is I will purposely push this 3 Newton. Okay, what is 3 Newton? 3 Newton, if you look at the specs, remember, whenever you do parallelogram or tip to tail, okay, forces orientation cannot change. So we have 3 Newton is actually 20 degrees below the line. Okay, that is 3 cm away. So same thing, I have the horizon here, 20 degrees below the horizon. Okay, then I measure 3 cm. Okay, which is 3 Newton. Okay, then after I will have the line, which is here. Okay, so now I effectively actually can connect the two forces together because using tip to tail. Tip of the first guy touches the tail of the second guy. Okay, and this is what we call tip to tail. Okay, tip of the first one touches the tail of second one. So what we do now is actually simple. So now what we do now is actually just connect the dot, which means from here, I'll connect this dot, this starting point. I'll connect to the end point. So once I connect, this is what we call the resultant force. Okay, so this is the resultant force, this is the resultant force. Label it double arrow, and after that put the labeling there, FR, okay, so that the marker know that is a resultant force. So two forces or two way of finding resultant force. Okay, two way. Either you can use a parallelogram or tip to tail. Usually what I advise students is you must be good at your parallelogram method. Parallelogram method is usually by step, you just follow monkey see, monkey do. There's not much calculations. Okay, tip to tail, I would say it's not that difficult, but just that sometimes you have to be careful of the angles. Okay, so no matter what, the first rule of thumb when we look at vector additions. Okay, remember for parallelogram, okay, for parallelogram, when we look at the adding, okay, you make sure that the first step you do is you copy the forces right down to the orientation. So if this is 60 degree, you copy. Okay, so if it's 3 Newton, okay, then after you do it accordingly. So example is here. So what I do is okay, this way. Okay, then after that, second one is remember the first step consists of labeling 5 Newton and 3 Newton. Then what I do is I will actually do the parallelogram method, which is I will copy this line onto the other end. Okay, using a slider, you know, like how to form parallel line, or I can actually find the interior angle. For example, if I know this is 60 degree, if I know this is 60 degree, I will know this is 120 degree. Okay, because this is parallel line. Okay, this parallel line means they are what we call interior angle. Okay, then after that, once you have the 120, okay, so what you do is I duplicate this line to the horizon again. Okay, so once I duplicate the line to the horizon, make sure you don't make this mistake. When you duplicate, remember, you only duplicate the line. Don't put arrow, because now you put arrow, you have 3 arrow. 1, 2, 3. 1, 2, 3. Okay, but the question only say 2 forces only. 2 forces, 3 arrow means arrow means forces. So which means one is mistake. So which means this one is actually a solid line or dotted line, but no arrow. Okay, so I close it. Now, so once I close it, okay, make sure all the forces are labeled. Then after that, this is my start, this is my end. So after that, I'll just connect it, okay, using a ruler, start to end. Okay, then after that, I'll measure the forces. Then you'll get the resultant force. Okay, so if I want to find, remember to label FR. So if I want to find FR, okay, I will just measure it. So it can be example like 7 cm. Okay, multiply by the scale, 1 cm is 1 unit. So you will be 1 cm is 1 Newton, so it will become 8 Newton. Okay, so this is what I mean by your parallelogram method. Each of the method, they have their own specification. For example, if it's tip to tail, tip to tail, you have your own specifications. Remember, tip of one force touches the tail of the other force. So that I can have a 40 degree. Okay, so this is my tip of first force. Then after that, my tail of the second force, which is 20 degree below the horizon, 20 degree. Okay, so this is what I mean by your tip to tail halfway through. So after that, what we do is this is the start point. This is the end point. So what you do is you join them together and they will have the final answer here. So final answer, label double arrow, label FR. That's the resultant force. Okay, so it's always, direction is always pointing from the start to the end point. Okay, so make sure you know where is the start, where is the end point. Okay, then after that, when you have the answer, FR, okay, measure the cm. Then after that, use the ratio, convert back again. Then you have the answer in Newton. Okay, so that will be the how we use the tip to tail. Okay, if you want a detailed example of tip to tail and parallelogram method, I have one video made for parallelogram and tip to tail. Just focusing on these two methods. Okay, I'll take it in the playlist here in chapter 3. Okay, you can actually refer to it once you are okay, or when you are ready to tackle this particular section. Okay, so in the meantime, okay, what we have is, okay, we have covered the first two sections. Okay, forces, what are forces, and a simple addition of vector addition or forces addition. Okay, so when you add forces or when you add any vectors, remember to use either one of the method, and to use that method effectively, it actually call upon practice so that you are familiar with the rules and how you form parallel lines, or how you get one tip of one force touch the tail of the other force, all these things. So you need to practice to be really good at it. Okay, if not, if I miss anything, or if I misrepresent anything, okay, by all means, okay, please leave your comments at my channel below at the video so that I can actually touch up or can actually improve on it. Okay, any feedback is also welcome. Okay, you can drop me an email, comments, or actually a message. Okay, if not, okay, see you for the next section of dynamics under force and pressure. Okay, thank you very much. Bye bye.